Okay, so welcome everyone to our very first lesson. Where in that lesson, we're going to be taking some time to understand the basics to using the C Sharp coding language within Unity. So that no matter what your experience level is at with the language or with coding in general, we'll all be on the same page and ready to start using it with FMOD. We'll be talking about how a game is able to run and perform the code that we write, and we'll also be getting into grips with the basic principles that we'll need, such as things like variables and functions. I'll also be providing links at the bottom of this video, or the bottom of this page you're watching this video on, that will provide you with some more detail on all the topics that we'll discuss, in case you want to learn a little bit more on your own time. Great, so let's start by creating a new script for us to practice with. We'll do this by right-clicking anywhere in our Project tab, and choosing Create, and going to C Sharp Script. Now we get to choose the name of our script, and I'm just going to call mine Player and pretend I'm using it to control my player character within this game. Once you've chosen a name, just hit Enter, and then give Unity some time just to compile the script and get it ready for us to use. Once Unity has taken some time to create the script, we can open it by double-clicking on it, and it'll either open in a program called MonoDevelop if you're using a Mac, or if you're using a PC and you downloaded it with Unity, it will open with Microsoft's Visual Studio, both of which are coding editors. So once you've opened your script, you should be presented with a page similar to this. This is our script, and every line you can see currently is what Unity provides for us by default. So let's familiarize ourselves with what's happening here. Now, the best way to read and interpret code is by reading one line at a time from top to bottom, as this is the order our code will be checked and performed in by Unity. So let's start at the top and work our way down. Now, our first three lines of code are called namespaces, which are these three at the top here. And we know this because they all start with the keyword using. Now, namespaces contain specific information for our scripts to access and use. For example, the namespace using Unity engine allows our script to use and then interact with specific Unity components, such as a game object's transform component. If I go back into Unity and quickly choose one of our game objects in the hierarchy tab by random, you'll see at the top of the game object in the inspector tab, they have a component called transform. This determines where in the world our game object is located. If I go back to our script, notice how all three namespaces end with a little semicolon at the end of the line. This is how we end a line of code, in the same way we would end a written sentence with a full stop or a period, telling our script that this line is finished and contains no further information. Now, we won't be looking too much into namespaces until later in the course, so don't worry about them for now. Underneath the namespaces, we have the beginning of our code. Whenever we create a script, we also create what's called a class of the same name as the script. Now, a class is a container for the information and behavior we want to create. They're used to create methods, functions, and variables, all of which we'll be talking about later on. You can also create subclasses within the script's main class to contain and store more specific information and use as an organizational tool for larger scripts. Now, notice that after the line that holds the class, we have a curly bracket after it instead of a semicolon. Also notice how when I highlight this bracket, the closed curly bracket at the bottom of the script is highlighted as well. Now, everything in between these brackets is where we place the information and behavior we want our class to use. This section is known as the body of the class. For now, we're going to ignore the word public and the monobehavior parts, as we won't be interfering with them much at all. Now, inside our main class is where we can start adding to our script. The first thing we're going to do is create a variable. Now, variables are a very common tool we'll be using throughout this course, as they are used to create and store information. There are multiple different types of variables, known as data types, for different types of information. One of the most common data types is the integer type, used for storing whole numbers. To create an integer variable, we first need to make some space in between our class and this first line of code here. So simply click on the space next to the open curly bracket and click enter a couple of times to give yourself some space. Then to create the variable, we first write the data type, which in this case is int, short for integer, followed by a name we'd like to give it. So for example, if I wanted to use this variable to represent a player's health, I might call it health. We can then give this variable a value to store and hold. Whenever we want to give a variable a new value, we add an equals operator after it, followed by a value. I'm going to give mine a value of 5. So to finish creating our variable, we end the line of code with a semicolon. Now whenever we use our newly created health variable, we'll be able to use the value we've stored inside of it. So to sum up, whenever we want to create a variable, we write it inside of our class area here. We start with the data type, which in this case is the integer data type. We can then choose a name, which in our case we've chosen health, and we can then add an equals operator followed by an appropriate value. And because we chose our data type as integer, we have to add a number to it. So in our case, we've chosen 5. We then end it with a semicolon to tell our code that this line has ended. Now, another common data type is the float data type. A float is used to store numbers in it as well, but unlike the integer, it could store numbers with decimal places. So for example, let's create another variable and start with the data type float. We can then give it a name. For example, we can call it speed, and we can then give it a value, something like 0.5. Now, whenever we're using float values or values with a decimal place, we have to follow the value with a lowercase f, otherwise Unity won't recognize it as a float value. Just like before with the integer variable, we simply end it with a semicolon. We can also use the Boolean data type by writing bool, which can only ever be true or false. An example of a Boolean might be one that is used to check to see if the player is on the ground or not. So let's call this Boolean player is grounded and set its value to true. The last data type we'll look at for now is the string data type, which can store characters and words. To create a new string variable, we can give it a name and a value to store, just like we did with the others. Now, just like how float data must always have a lowercase f following it, string data must always be written in quotation marks. Now, alternatively, we don't have to set values to all of these variables straight away. If I were to write any of these without a value next to them, say for example the health variable, its value would become whatever the default value is for that data type. So integers and floats would contain a value of 0, Booleans would be false, and strings would not contain any characters. Moving on down our script, we next see some green text starting with 2 forward slashes. You can use this to temporarily remove lines of code without deleting it, which you may do for testing purposes or to write notes for yourself or to other programmers in order to explain what your code is doing. In this case, it's telling us how to use the next part of our code. I'm going to remove them from mine to keep things nice and clean, but feel free to keep them if you need them. Now, the parts that were underneath the green text are also very important. These two parts here are called functions, sometimes also known as methods. They are used for many different purposes, such as making calculations, performing behavior, or checking to see if certain things have happened in our game, just to name a few. We know these are functions based on a few things, so let's quickly break them down. Notice how they both start with the word void. This word is used when creating functions and tells us that this function doesn't create a new value for a specific data type, something that some functions can do, but don't worry about what that means exactly for now. The next part is the name of the function, which in this case is the word start. We then have two parentheses or brackets, which are used for creating parameters for our function. But again, we can leave these blank and not worry about them until later. The last part is the body, which again is represented by an open curly bracket and a closed curly bracket. This is where we can put everything we need to inside our function, just like we did with our class. It's important to note that these two functions we are provided with behave in specific ways. You may have heard of the term frames per second before when referring to video game performance. Games work by showing you a series of still images one after the other really fast, which creates the illusion of motion. Similarly to how if you were to doodle on every page of a sticky notebook and flick through the pages, the collection of doodles would appear to be moving as one. These two functions are specifically used in Unity's version of C# to do whatever we tell them to do in their bodies at specific frames. We're actually able to use these two functions thanks to the monobehavior part of our class. Without it, the scripts wouldn't recognize the functions and give us an error. The start function will do what we tell it to on the very first frame that this script is active for, whereas the update function will on every frame that is run whilst the script is active. We can use other functions that behave differently, which I'll provide a link for in the bottom of this video, but for now let's see if we can take some of our variables we created and change their values within these functions. To start with, I'm going to temporarily disable the float, boolean and string variables we created and focus on the integer for this demonstration. Now I can do this by either adding the 2 forward slashes to each of them, or by typing a single forward slash followed by a star at the beginning of the section I want to disable. Then all I have to do is, at the end of the section, write a star and another forward slash. As you can see, everything in between the forward slashes and stars has now turned green, meaning the whole section is disabled. Okay, so let's start by assuming that we're going to be activating this script or turning it on as soon as the game starts. Let's take our health variable and reference it in our start function simply by writing its name, which is health. Now we could end it here. This would reference the health variable on the first frame of the game, but on its own, this isn't very interesting. So let's change its value. By writing equals 10 and ending the line, we'll be changing the health of the player from 5 to 10 as soon as the game starts. We can then test to see that this has worked by writing a very specific command in our start function called debug.log. And it looks like this. Now the debug.log command works by taking whatever we put inside its parentheses and displaying that information into Unity's console tab. So let's write debug.log health and then save our script and check back in with Unity. To save our script, all we have to do is hit Control and S on a PC or Command and S if you're using a Mac. Then all we need to do is go into Unity. And if we look at the bottom right of the screen, you'll notice a little spiral loading in the bottom right. That represents Unity compiling our script and checking that we haven't made any errors before we can use it. Now that the script has finished compiling, I'm going to quickly create an empty game object in Unity, as we need to attach our script as a component to an object for it to run. So to do this, we just have to go up to our hierarchy tab, choose Create, Create Empty Game Object, and you'll see at the bottom it has a new object called GameObject. Then to add the script as a component, we have two options. We can either choose Add Component in our Inspector tab on the GameObject we'd like to add it to, and write its name, which in our case was Player, and then find the script we're after, or alternatively, we can select the script from our Project tab and simply drag it into the Inspector tab. Now that I've added the component to our game object, I'm going to quickly select the console tab, as this will be where our value of our health variable is going to be displayed. Now I can run the game, and on the first frame, as soon as it starts, we should see the value of our variable appear here. There we go, just like that. Now what if for some reason we wanted to change a variable every frame that it is run? To do this, we'd go back to our script and we'd use the update function. I'm going to demonstrate this by using the speed variable, so I need to quickly remove the star and the forward slash icons from in front of my variable so I can use it again. So instead of just changing the number of its value, let's instead use an operator to change it. The main operators we can use work the same way they do in mathematics. We can add, subtract, divide, and multiply. So let's try and multiply our speed variable by 2 every frame. Remember, we can assign a new value to a variable by adding the equal sign after it. So let's write the name of our variable, which is speed, and follow it with the equals operator. We now need to write the name of our variable again to tell the code that we're going to take whatever value the speed variable is at currently, which in our case is 0.5, and then multiply that by 2. So let's write speed multiplied by 2. A good way to understand what's happening here and how our code interprets this information is to read it out loud to ourselves as if we were commanding our code to do something for us. In our case, that command would sound something like this. On every frame that our game is run, take whatever value our speed variable is currently and change it to whatever value that is multiplied by 2. Let's again add the debug.log command to test that this has worked, but to make things a little clearer for ourselves, I'm going to quickly reactivate the string variable we created earlier. I'm going to change its name, as I'm no longer going to be using it for a color. And I'm also going to be changing its data to speed colon. Then in our update function, I'm going to write the debug.log command. And then I'm going to write the name of the display variable. Then I'm going to add a plus sign and add the speed variable. So inside our console tab, our debug.log command is first going to display our display variable, which will be whatever data is inside of it, which we know is speed colon space. It's then going to display whatever's in the speed variable, which should be the answer to this mathematical problem we've set up here. Now notice how I separated them with a plus sign. This will tell our command to display two separate pieces of information. So now let's save our script, go back into Unity, wait for our script to finish compiling, and then once it has, we will play our game and see if our console tab will display our variables. Once our game starts playing, we should see in our console tab that our speed variable will be multiplied by 2 every frame, as well as the speed colon space string data that we added to the display variable. And as you can see at the bottom here, it's working perfectly. Okay, so that was half the basics to C# we'll need to know in order to implement our audio. We've looked at how we can store and control values in our script. We've also learned how we can use Unity functions to perform actions at certain times. And in the next video, we'll look at how we can create our own functions, as well as attributes, access modifiers, statements, and more. Before all of that, try and create your own scripts, write some simple code, just like we've done today, just to get a feel for what you can and can't do. Then once you feel ready, jump straight into the next lesson. So, thank you for watching this one, and I'll see you in the next one.